Hello, welcome to Chapter 3, Learning Plan 2. We are talking about the visible PC in this learning plan, and I am going to go through the lecture, and up on the screen you will see the lecture notes for this chapter. Go ahead and print out your own copy or have it open electronically. Fill in the blanks as we go along. Then you can use this as a reference when you're taking the quiz for this chapter. So, to start out with, we're going to look at the 4 stages of the computing process. At a basic level, a computer consists of hardware, an operating system, and programs. These items are responsible for the 4 stages of computer function: input, processing, output, and storage. To accomplish something with a computer usually requires activity in all 4 stages. Input is when we get data into the system. Processing is the manipulation of that data in some fashion to provide information. Output is the visible result of the processing activity in a form that's useful to you. And storage, retaining that information so that it is available should you want it again or wish to do further processing with it. All parts of the computer have to be functioning properly for these 4 stages to occur as you desire. In Hardware 1, we're going to look primarily at the hardware of the system and how it accomplishes these 4 stages, and what to do if they fail to accomplish their tasks. Now, one of the most important things to remember when working on computer hardware is to protect it from electrostatic discharge or static electricity. Anytime you open up your computer case or handle an internal component, there is the risk of damage from ESD. Generally, there are 3 types of possible damage: upset failures, degradation failures, and catastrophic failures. Any of these can be caused by a shock that you may not even feel, so protection is essential. Protect the equipment by using an anti-static wrist strap and anti-static mats. If you've never used either one and think you've never had problems, you're probably wrong. ESD damage often doesn't show up right away, but usually long after the actual static discharge occurs. To protect working components that are being removed from a system, store them in an anti-static bag. Since all new components come in some form of anti-static packaging, these are ideal to use for storage of older equipment that's being replaced. Now, many discrete components make up your PC. Today we're taking a very brief look at many of them and are discussing their general characteristics. All will be examined in more detail in the coming weeks. First, let's look at the items that we think of as making up our standard home or office desktop computer. Keyboards are one of the 2 primary input devices used with PCs. These may connect with DIN or AT connectors, mini DIN or PS2 connectors, USB connectors, or some form of wireless connection. Keyboards come in different forms. The standard keyboard has been around for quite some time, but there are also ergonomic keyboards available that reduce the stress for people who spend many hours typing. These split the alphanumeric keys into 2 groups so that your hands don't have to be held so closely together. This reduces strain on neck and shoulder muscles and makes it possible to use a keyboard for longer periods of time without discomfort. They take a little while to get used to, but if you have to do a lot of keying, I highly recommend them. Regardless of form or connection type, keyboards get very dirty. Keep them clean. Do this with canned air, a general purpose cleaner, or rubbing alcohol. As a last resort, you can even stick it in the dishwasher. Low heat and air dry. It does work. Now, I only recommend this with wired keyboards. Do not attempt this with a wireless keyboard. You want to put a plastic wrap around the connector on the end of the cable when you put it in the dishwasher. But if the keyboard is so messy that you would be throwing it out otherwise, I think it's worth a try. Mice are the other primary input devices. Like keyboards, they can connect via a mini DIN or PS2 connector, USB, serial port, or wireless connection. Mice come in different styles. The standard, now almost obsolete mouse uses a ball which turns rollers which send signals interpreted by your processor. Optical mice use light to detect signal changes. The traditional mouse moves on your desktop, or you can use a trackball, which is stationary and only the ball moves. Other pointing devices include touchpads or button pointers like those found on laptops, or styluses and pens like those that can be used with tablet PCs. Monitors are one of the two primary output devices on your PC. These may be a flat screen LCD display or the older CRT and can be either analog or digital. They connect to the video port. Printers are the other primary output device providing hard copy. They generally connect to your system via the USB or parallel port or use wireless transmission. And speakers and headphones give us audio output instead of or in addition to visual output from other devices. Devices that sit outside the case must connect to the motherboard inside the case, and they use different types of connectors to do this. The motherboard or expansion card has ports of different kinds that these connectors attach to. Each connector and port has its own characteristics and specific name. DIN, D-I-N, connectors are small and round. They come in two sizes, the obsolete 5-pin DIN and the more common 6-pin mini DIN, also referred to as the PS2 connector. The sockets are always female. The connection on the cable is always male. You'll still find these on the backs of many systems for the connection of keyboards and mice. USB connectors are short, flat, rectangular ports and connectors. They are now the most common connector for many devices and can be used by keyboards, mice, printers, cameras, scanners, and so on. These devices are hot swappable. You can connect and disconnect them while the system is on and without rebooting your operating system. You can also daisy chain USB devices through a USB hub, putting many devices on the same port through the hub. IEEE 1394 or IEEE 1394 or FireWire connectors are used on devices that need high-speed data transfer. New systems have these ports built in, but if yours doesn't have one, you can install an expansion card that has the port. Like USB, these are hot swappable and plug-and-play compatible. There are two sizes here. The 4-pin connection requires a separate power supply for the device. The 6-pin size provides power along with data transfer through the single connector. DB connectors have a trapezoidal shape and look like a sideways D. They have either pins, which makes them male, or holes, which means they're female. They are identified by whether they are male or female and the number of pins or holes that they have. For example, a female DB25 is an LPT printer or parallel port. RJ connectors are the small connectors that are commonly seen on the end of your phone or network cable. In PCs, we use one size, the RJ11, on modems for phone lines, and a second size, the RJ45, on network cards for Ethernet or cable modem connections. And lastly, audio connectors are the smallest round connector on your PC. These are found on sound cards for speaker, microphone, line in or line out cables. Now those connectors that we just named are commonly found on the back or front of system cases or in laptops on the sides. These may be mounted directly on the motherboard, or they may be on expansion cards which are inserted into slots on the motherboard. Common system devices and their connections include monitors and video connections. Most commonly, video cards have either a female DB 15-pin connector with 3 rows of holes, sometimes called a VGA port, or they may have the DVI digital video interface. You may also find video cards with S-video ports or an HDMI connector for high-definition multimedia interface. Sound cards do 2 things. They take digital information and turn it into sound for output through speakers. Second, they take sound input from a microphone and turn it into digital information. Depending on the type and quality of sound you want from your system, you may require only onboard sound, where the sound card functions and ports are built into your motherboard. Or you may want a separate expansion card for better sound. Regardless, you'll have at least 2 miniature audio jacks for microphone and speakers. There may also be a few extras for surround sound. To consolidate things, you may find the SPDIF connection for surround sound. Also on older sound cards is a DB15-pin game port or MIDI port for joysticks or electronic musical instruments, although today these devices often connect through USB ports instead. Network cards allow PCs to connect to larger systems of PCs, whether that's a local area network, a wide area network, or the internet. These cards are generally known as NICs, or network interface cards, and commonly they have an RJ45 port for Cat5 or Cat6 network cable. Modems let your PC communicate with other PCs over phone lines or broadband lines. Dial-up internal modems are found on expansion cards, and external dial-up modems are separate devices that would connect to your PC's serial or USB port. These have 1 or 2 RJ11 ports and visually resemble network cards with their 1 RJ45 port. Serial ports were the first standardized port on the case that allowed people to add devices without opening the PC. These take a stream of single-bit data and convert it into a form that your processor can understand. Then they take the output from the processor and translate it back into serial data for use by the device. They were once used for everything from printers and mice to external modems. Today they are often unused, but are sometimes provided for backward compatibility. Parallel ports were once the standard connections for printers for a very long time. There are still some very reliable printers in use that connect to parallel ports, so again, these are included for backward compatibility. On parallel printers, you will find the last Centronics ports. These connectors have the same shape as DB connectors, but they will have flat contacts instead of pins. eSATA ports allow some external hard drives and optical drives to connect to the outside of the case. Inside the case. Now, there is no one universal method for attaching covers to cases, so you'll find a great variety in the ways in which you might access the components inside. But once you do get the cover off, you're going to find these items. The CPU or processor. This is the brain of your PC, the one that does the bulk of the computational work. This component sits on the motherboard inside the case or tower. Because of the speeds at which today's processors operate, they generate a lot of heat. Too much heat can damage or destroy these sensitive components, so one or more devices will be used to dissipate that heat. Heat sinks and cooling fans are the common components associated with processors for the removal of excess heat, although other cooling devices are becoming more common. RAM, or Random Access Memory. RAM stores data and instructions currently being used by your processor. We measure quantity or amount of RAM in bytes. Since today's systems can use a great deal of RAM, these measurements are commonly in gigabytes. Over the years, RAM too has changed in form. Packages or forms of RAM have ranged from DIPs to SIMs to DIMMs. If you buy a system today, your RAM will come in some form of DIMM type. The original DDR RAM had 184 pins. DDR2 RAM has 240. DDR3 RAM also has 240 pins, but the sticks are notched differently along the bottom so that they only insert into motherboards with DDR3 RAM slots. We'll examine RAM in more detail in a few weeks. The motherboard, or main system board. This is the main circuit board inside your case or tower. It is the board everything else is mounted on or connected to. On the motherboard, you'll find various sockets for things to mount in, such as power, drives, internal and external devices. There are also a few devices mounted directly on the motherboard. Motherboards also have expansion slots, so you can add components. These slots can hold expansion cards to provide additional functionality. Some devices you might add as expansion cards are sound, network connections, modems, and so on. A power supply. Your system needs power to run, and the power supply provides the proper power. Computer components require DC power, so the power supply actually converts the AC coming in from the outlet to DC. Because most devices require much less power than the 110 volts provided by a standard outlet, the power supply takes that voltage and steps it down to the proper voltage for your components. So a power supply is really misnamed. More properly, we can think of it as a step-down transformer. Each system also has one or more drives. The hard drive is the primary device used for data storage in our PCs today. Interestingly, the first hard drives had capacities of 5, 10, or 20 megabytes. Today's drives have capacities in the gigabytes, ranging from several hundred to over a terabyte. Hard drives mount inside the case but do not need to be accessible from the outside. They must have a connection to the motherboard, and they also require power. Serial ATA drives use data cables with 7 pins and wires and a specialized power connector. The older parallel ATA ribbon cables for hard drives have 40 pins and either 40 or 80 wires. These would use the large power connectors off of the power supply called Molex connectors. Optical drives. These became standard on PCs nearly 20 years ago, beginning with CD-ROM drives. These drives worked with data CD-ROM discs and some music CDs. Now, we commonly use DVD drives, which store video or larger amounts of other data. Nearly every system comes with some kind of data burner, drives that will let you save data to writable or rewritable optical discs. CD, DVD, and Blu-ray drives mount inside the case and are accessible from the outside. They are often serial ATA optical drives, which connect the same as SATA hard drives do. Also available are the older parallel ATA drives, which use the 40-pin data cables to connect to the motherboard, and these drives get their power through Molex connectors. The floppy drive. This was the first storage device provided with PCs. Computer manufacturers today leave out these drives, but data can remain intact on a properly stored floppy disk for many years. So, if you have floppy disks with data files on them, you may want to invest in an external USB connection floppy drive. For systems that have installed floppy drives, these connect to the motherboard via a data ribbon cable that has 34 wires, and they get power off of the power supply through a mini connector. That's a very brief look at many of the main components of your PC. We'll be looking at each one of these in depth during the coming term.